नमस्कार बच्चों, मेरा नाम धन्या और हम लोग सीख रहे हैं ग्रेड 11 ऑर्गेनिक केमिस्ट्री लेसन ऑन नोमेनक्लेचर ऑफ साइनाइड्स. Okay, so cyanides is cyanide is C triple bond N functional group, and it has a secondary suffix nitrile. Okay, and it is also a terminal functional group. That means it has a carbon. Okay, and terminal functional group. So it comes at the end of the chain. So it is a terminal functional group. Okay. So suppose you are asked to name this compound. So you can see that it has only one carbon atom. So one carbon atom means it is methane. And what is the secondary suffix you will use? Nitrile. Because this functional group has a carbon atom, it is given a number. Okay. Now, if you have this compound, so you can see the carbon atom that has the functional group is given number 1, and there's another carbon atom, so number 2. So 2 carbon atom means ethane, nitrile. Okay, so let's draw some bond line structures and name it. So if I have a structure like this, C triple bond N, I have a double bond over here. So this is carbon, 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 carbon. Right, so here it is CH3. Okay, here also it is CH3. And definitely this carbon, which has the functional group, is given number 1, 2, 3, 4, 5. This is the longest chain, which includes most of the bonds, double bonds. Yes. So there are 5 carbon atom, and you can see there is a substituent methyl group at the 3rd position. So what would be the name? At the 3rd position, I have methyl, 3-methyl. How many carbon atoms are there in total? 5. So pent, 2-ene, because at the 2nd position, you can see there's a double bond, pent, 2-ene. And the nitrile is at the 1st position. You may give 1 nitrile or you may just write nitrile. It's up to you because the nitrile is at the 1st position. So you can just write 3-methyl pent 2-ene nitrile or 3-methyl pent 2-ene 1 nitrile. Okay, I hope I'm clear. Coming to the next compound. Suppose if you're asked to name this compound, C triple bond N. Yeah, there's a CH3 group. Yeah, there's a CH3 group. And here also there's a CH3 group. Okay. So definitely the numbering will be from the functional group. This is number 1, number 2, and number 3. So definitely you have 2 methyl substituents at the 2nd carbon atom, right? So what would be the name? 2,2-dimethyl. And how many carbon atoms are there in the straight chain? Propane. You can just write propane nitrile, or you can write propane 1 nitrile because the nitrile is at the 1st position. So this is the name of the compound. Okay. Now, coming to the next question. So these are just some easy ones. You know how to number it, etc. We have done the rules in so many videos, previous videos. Suppose you have another compound, CH2, C triple bond N, and you have a cyclic compound attached. So how would be the numbering, or who would be the main chain? Definitely the one that has the functional group will be the main chain. So this is our main chain, number 1, number 2. At the second position, I have a cyclic substituent, right? So this becomes our substituent because the one that has the functional group is our main chain. Okay, so at the second position, our substituent, the substituent also we will number it. So 1, so I'll number it in a different color so that it's easy. Number 1, you can also write 1 dash, 2 dash also. So 1, 2, and 3. So at the second position, because it's a cyclic substituent, cyclic substituent with 3 carbon atoms, so cycloprop. And at the second position, I have a double bond here. So cycloprop 2 in, because it's a substituent, I write enyl, like we write methyl, ethyl. Because it's a substituent, we write enyl. Okay, I close the bracket. And then how many carbon atoms are there in the main chain? This is our main chain. Ethane. And at the first position, I have nitrile. You may mention number 1 nitrile, or you may just write ethane nitrile. It's up to you. Okay, I hope I'm clear. So this is enyl because it's a substituent. At the second position, there is a double bond, so ene, and yl because it's a substituent. Okay, I hope I'm clear. Coming to the next question. CH3, C, C, C triple bond N. I'll make it more clear. C triple bond N. CH3. There should be an H here to adjust the bonds. So this is a cyclic. So over here, you can see, because there is a functional group, this will be a main chain, 1, 2, 3, 4. So this becomes our cyclic substituent. So this is our cyclic substituent. And this is our main chain, the one that has a functional group. Okay, now, so at the third position, I have the substituent. This is our substituent, cyclic substituent, which also I have to number because you can see there is a double bond. So I have to number it. So 1, 2, 3, 4. So at the third position, I have cyclo, and the cyclic substituent has 4 carbon atoms. So bute. At the second position, there is a double bond, bute2ene yl, because it's a substituent. Okay, just like methyl, ethyl, because it's a substituent, yl. So now coming back to the main chain, this is our main chain. At the second position, I have again a substituent, 2-methyl. Then there in the main chain, there are 4 carbon atoms in total. So butane, and at the first position, I have butane-1-nitrile. I hope I'm clear here. Taking another example, suppose if I have this kind of a compound. So there is 1 carbon atom. So this is the functional group. So this is given number 1. So I would name it 1. This is our substituent then. This is our substituent. It's a cyclopentyl group. Cyclopentyl. Because it's a substituent, so just like methyl, propyl, etc., we write cyclopentyl because it's a substituent. Cyclopentyl, and because there is in the main chain, there's only 1 carbon atom, so I write methane-1-nitrile. But over here, this numbering is wrong because you can see this functional group has 1 carbon atom and it is directly attached to the ring. So it is directly attached to the ring if you see. So in this case, we don't number it. Instead, we use the suffix carbonitrile. So we don't number it. So we write, instead, we write cyclobutane. Oh, sorry, this is cyclopentane. Cyclo, because I have 5 carbons, right? Cyclo. So we write cyclopentane carbonitrile. Why? Because the carbon atom of the functional group is directly attached to the ring. Okay, I hope this is clear. So this is a special case. So this naming is wrong because the terminal carbon, because this is the terminal functional group which has a carbon and it is directly attached to the ring. Okay, so this was discussed when we were discussing aldehydes, acids, and even the acid halide, all these we had discussed this case, the special case. Okay, so here, if I have this compound, carbon, so this is question number 1. And another question I would give, question number 2. So, in the first question, you can see here we number this carbon, number 1, 2. This is the main chain because this is a functional group. So functional group, the chain that has the functional group is given is the main chain. Okay. So at the second position, I have a cyclic substituent. So 2-cyclohexyl. In the main chain, there are 2 carbon atoms. So ethane-1-nitrile or ethane-nitrile. It's up to you. Okay. So here the functional group, the carbon of the functional group is not directly connected to the ring. So we name it this way. Okay. But in the second case, if you can see that the functional group has a carbon atom and it is directly attached to the ring. So in this case, we don't number it. Instead, we write cyclohexane carbonitrile. carbonitrile. Why? Because the carbon of the terminal functional group or carbon of the functional group is directly connected to the ring. Okay, so this is the special case. Okay, so this is the special case where carbon is directly connected to the ring. Okay, so one more special case I would like to discuss here. So this was discussed when we discussed acids, alcohol, yes, even aldehyde. One more special case where I have all the three functional group are the same, that is the nitrile group, and all of them have carbon atom. And if I number it from here 1, 2, 3, 4, 5. However, I try to number, definitely I will miss out any one of them. So this is the symmetric case. This was also discussed before. So in this kind of symmetric case, when all the functional group are the same and they contain carbon atom, we must not miss out any of the carbons. So here also, what do? Here we don't number it. Instead, we write, we don't number the carbon of the functional group. Instead, we write, so this is the special case of symmetry. So this was also discussed when we discussed acids, etc. So here there are 3 carbon atom in the main chain. So propane, we don't number the functional groups. So propane, at the first position, second position, and the third position, I have carbonitrile. So how many carbonitriles are there? 3 carbonitriles are there. So tri-carbonitrile. Okay, so students, we discussed 2 cases where we can use carbonitrile. This was discussed before also. One is the case when the carbon atom of the functional group is directly connected to the ring. And in the second case, it was a symmetry case when all the functional group are the same and they all have carbon atom. We cannot ignore any of the functional group, so we don't number any of them. So here also we will use the term carbonitrile. Okay. Here, students, one more question. Here also, you can see the carbon atom of the functional group is directly connected to the ring. So we have to number the ring because, as you can see, there are a lot of substituents. Here there's a substituent, cyclic substituent, and this is cyclopropyl and cyclopropyl. And here, this is ethene group. So this is ethenyl. Okay, so here, because the functional group is directly connected to the ring, we will use the term carbonitrile. So first we write down the names of the substituents and first we number it. So this is the first carbon atom. So this is the second because here there is a substituent present. This is the third carbon atom, fourth carbon atom, and the fifth carbon atom, sixth carbon atom. So here, this is E and this is C. So definitely we name it according to the alphabetical order. At the third position, I have cyclopropyl group, cyclopropyl. And at the second position, I have ethenyl group. Because it's a substituent, so we don't write ethene, ethenyl. Okay, and there are 6 carbon atom in the ring. So cyclohex. And the double bonds are at the second position and at the fourth position. 2,4-diene, because there are 2 double bonds. And for CN that is connected directly to the ring, we use the term suffix carbonitrile. I hope I'm clear, students. Thank you. Have a great day.